The year was 1939. Most of rural America still lived without electricity. Indoor plumbing was a luxury many could only dream of. Glenn Miller's smooth melodies drifted from scratchy radios, while Billie Holiday's voice carried the weight of a nation on the edge of change. A brand-new automobile could be yours for under $1,000. And at Mare Island Naval Shipyard, just north of San Francisco, a young welder named Edward Ted Nelson was about to change the course of World War II. But no one knew it yet. No one believed him. Not his supervisors, not the Navy brass, not even his fellow workers. In the world of shipbuilding, things had been done the same way for decades. Why change? Why rock the boat? Why listen to some ordinary welder with crazy ideas? This is the story of how one man's obsession, working night after night in his garage, would save the United States Navy 50 million man-hours and help win the greatest war the world had ever known. Mare Island Naval Shipyard had been the Navy's first base on the Pacific coast since 1854. By 1939, it was a sprawling industrial fortress, a city unto itself. Smoke rose from dozens of buildings. The clang of metal on metal echoed day and night. Ships in various stages of construction and repair filled the dry docks like massive steel patients awaiting surgery. During the years leading up to World War II, Mare Island specialized in submarines. These underwater predators were the Navy's secret weapons, sleek and deadly. But they had a problem. Actually, every ship had this problem. It was a problem that had plagued naval construction since the dawn of steel vessels. The problem was wood. Wood decking. To be precise, every submarine, every battleship, every aircraft carrier needed wooden decking on the topside. The wood provided traction, insulation, and a barrier against the relentless corrosion of salt water. But installing that decking was a nightmare. The process was simple in theory, maddening in execution. Workers would drill holes through the wooden planks. Then they'd push threaded bolts down through those holes until they contacted the steel frame below. But here's where the problem got ugly. To secure those bolts, workers had to go underneath the deck, deep underneath, into the bowels of the ship. And there, in cramped, dark, barely accessible spaces, they would erect scaffolding. Level after level of wooden scaffolding, often reaching dozens of feet high inside the hull. Picture it. Hundreds of workers climbing up and down these temporary structures, wrestling with heavy tools, reaching up to thread nuts onto bolts they could barely see, then tack welding those nuts to prevent them from vibrating loose. The scaffolding alone took days to build. The installation took weeks. The labor costs were staggering, and this was just for one ship. Mare Island was preparing for war, though America didn't know it yet. Ships needed to be built faster, repaired faster. Everything needed to move faster. But you can't rush scaffolding. You can't hurry the tedious process of crawling through the underdeck, fighting gravity, fighting time. Ted Nelson watched this madness every single day. And Ted Nelson was not the kind of man who accepted madness. Not much is known about Ted Nelson's early life. He wasn't from a wealthy family. He didn't have an engineering degree from some prestigious university. He was just a welder. A skilled one, yes, but still just a working man with calloused hands and grease under his fingernails. But Ted Nelson had something that couldn't be taught in any school. He had the mind of an inventor. More than that, he had an obsession with solving problems. When he saw something inefficient, something wasteful, something stupid, and the scaffolding process was all three, he couldn't let it go. It gnawed at him. It kept him awake at night. It followed him home. And that's where the story really begins. In Ted Nelson's garage. After putting in a full shift at Mare Island, while other men went home to relax, to listen to the radio, to play with their children, Ted Nelson went to his garage. Night after night, week after week, month after month. His neighbors must have thought him mad. The lights burning late, the sounds of welding, grinding, testing, the smell of hot metal drifting into the California night. What was he doing in there? He was building a gun, not a weapon of war. Not yet, but a gun nonetheless. A welding gun. Something that had never existed before. Something that would eliminate the need for scaffolding entirely. Something that could attach wooden decking to steel frames from the top side. In a fraction of the time, with a fraction of the labor. The concept was deceptively simple. The way all great inventions seem simple after someone finally thinks of them. Nelson envisioned a handheld device that looked something like a drill press. You would load a threaded stud into the gun. Then you'd position the gun over a pre-drilled hole in the wooden decking. The stud would extend down through that hole until it made contact with the steel frame below. Here's where the magic happened. When you triggered the gun, an electromagnetic coil would energize, lifting the stud off the steel surface just enough to create a gap. A split second later, an electric arc would fire across that gap, reaching temperatures of thousands of degrees. The tip of the stud would melt, the steel below would melt, and then, in one violent, beautiful instant, the spring-loaded gun would plunge the molten stud down into the molten base metal. Total penetration weld from the top side. In seconds, no scaffolding, no climbing into the underdeck, no threading nuts in the dark, no tack welding, no wasted time. It was brilliant. It was revolutionary. It was impossible. At least, that's what they told him. Ted Nelson's first attempts failed. Of course they did. Welding technology in 1939 was crude compared to today. Arc welding existed, yes, but it was imprecise, dangerous, and difficult to control. The idea of automating it, of making it happen in a split second through a spring-loaded gun, seemed like something from a science fiction pulp magazine. But Nelson kept testing, kept failing, kept refining. He experimented with different stud designs, different spring tensions, different electromagnetic coil configurations, different timing sequences. His hands bore the scars of countless burns. His garage became a laboratory of trial and error. And slowly, painfully, impossibly, the gun began to work. The studs welded. The joints held. The process took seconds instead of hours. Ted Nelson had done it. Now he just had to convince the United States Navy. Picture the scene. A young welder, probably with grease still on his work shirt, approaching his supervisors at Mare Island with a wooden crate containing his homemade welding gun and a fistful of test samples. "I've got something to show you." The supervisors were busy men. Ships don't build themselves. War clouds were gathering over Europe and Asia. The Navy was preparing for a conflict that seemed inevitable. They didn't have time for every worker with a crazy idea, but Nelson was persistent. He set up his demonstration, loaded a stud, positioned the gun, pulled the trigger. A flash of light, a sharp crack, the smell of ozone and hot metal, and there it was, a perfect weld from the top side. In 5 seconds. The supervisors looked at each other. Then they looked at Nelson. Then they said, "No." Why? Why would anyone reject something so obviously superior? Because naval shipbuilding was bound by tradition, by specifications that had been written years before, by procedures that had been approved by committees and subcommittees and boards of inquiry, by the simple, terrible inertia of bureaucracy. The scaffolding method worked. It was proven. It was documented. It was safe, sort of. It was what we've always done. Why risk something new? What if Nelson's gun failed? What if the welds didn't hold in rough seas? What if something went wrong and ships started sinking because some welder had a bright idea in his garage? The answer was simple. Stick with what we know. Ted Nelson was thanked for his time. His gun was noted for the record, and he was sent back to work. But Ted Nelson had not come this far to give up now. He kept pushing, kept demonstrating, kept making test welds and documenting their strength. He brought in engineers who would listen. He showed them stress tests. He showed them time studies. He showed them the mathematics of how many man-hours could be saved. how many ships could be built faster, how much money could be saved. And slowly, reluctantly, minds began to change. By 1939, Mare Island finally granted Nelson something precious: a leave of absence, not to go on vacation, to develop his invention, to start a company, to manufacture these impossible guns and make them real. But Nelson needed more than permission. He needed a patent. He needed credibility. He needed the Navy to officially recognize what he'd created. On May 31, 1941, Edward Ted Nelson filed his patent for the stud welding gun. 6 months and 1 week later, on December 8, 1941, the United States entered World War II. The timing couldn't have been more perfect. Or more terrifying. The attack on Pearl Harbor changed everything. In a single morning, December 7, 1941, the Japanese Navy struck the American Pacific Fleet with devastating precision. Battleships burned and sank. Thousands died. America's naval power in the Pacific was crippled. And suddenly, the United States needed ships. Desperately. Immediately. More ships than had ever been built in the history of the world. Submarines to hunt enemy vessels. Destroyers to protect convoys. Battleships to project power. Aircraft carriers to launch waves of fighters and bombers. And cargo ships. Thousands of cargo ships to carry the weapons, the fuel, the food, the ammunition, the vehicles, the everything that a global war demanded. Mare Island went into overdrive. So did every other shipyard in America. The Norfolk Naval Shipyard, Philadelphia, Boston, the private yards at Newport News, Bethlehem Steel, Kaiser's revolutionary facilities in Richmond, California. They were building Liberty ships now, emergency cargo vessels designed for mass production. The design was simple, almost crude, but they could be built fast, really fast. Henry Kaiser's yards would eventually complete ships in as little as 4 days. But even Kaiser's revolutionary assembly line methods couldn't solve the decking problem. Not without Ted Nelson's gun. The Nelson stud welding process, as it came to be officially known, spread through the shipbuilding industry like wildfire. Submarines were the first to adopt it, Mare Island's specialty. The wooden decking on submarine topside decks could now be installed in a fraction of the time. No more massive scaffolding projects inside the pressure hulls. No more weeks of labor for a job that could now be done in days. Then battleships. Then aircraft carriers. And then the Liberty ships. Picture the scene at Kaiser's Richmond Shipyard No. 2 in 1942. The yard was a madhouse of industry. Prefabricated sections arrived by rail from all over the country. Massive 250-ton modules, pre-welded at factories in the interior. Cranes lifted these sections into place. Welders swarmed over them like ants, joining them with thousands of feet of weld seams. But the decking still needed to be attached. Thousands of studs, ship after ship after ship. With Nelson's gun, a single worker could install decking that would have previously required a team of men and days of labor. The gun was spring-loaded, timing-controlled, and nearly foolproof. Load the stud. Position, trigger. Move to the next hole. Load, position, trigger. The rhythm was hypnotic. The efficiency was staggering. Time studies showed the results. What once took 10 men a week could now be done by 2 men in a day. Multiply that across hundreds of ships. Multiply it across all the shipyards in America. Add in the military vessels, the repair jobs, the refits, the battle damage repairs. The numbers were astronomical, but Ted Nelson's invention did more than just save time. It saved lives. Working underneath decks, building scaffolding, climbing in cramped spaces with heavy tools. These were dangerous jobs. Men fell, tools fell, scaffolding collapsed. Injuries were common. Deaths happened. Nelson's process eliminated almost all of that risk. The work was done topside in the open, with a handheld gun that weighed less than a sledgehammer. The danger didn't disappear entirely. Arc welding is always dangerous, but it was reduced by orders of magnitude. Fewer injuries meant more workers available. Fewer deaths meant more experienced hands staying on the job. The human cost of shipbuilding dropped as the production rate skyrocketed. And the quality? The quality was better. A weld created by Nelson's stud gun achieved complete penetration. The molten stud metal mixed completely with the molten base metal. The joint was as strong as the materials themselves, maybe stronger. Compare that to the old method. A threaded bolt held by a nut, tack welded in place by a tired worker in a cramped space who couldn't see properly and just wanted to move on to the next one. Those joints worked, sure, but they weren't perfect. They loosened over time. They corroded. They failed. Nelson's welds didn't fail. The Navy tested them, subjected them to stress tests, vibration tests, salt spray tests. The studs held. The decks stayed secure. Ships went to war with decking that could withstand the pounding of storms and the shock waves of nearby explosions. It worked. After all those rejections, all those doubts, all those nights in his garage, it worked. As the war progressed, Nelson's company, Nelson Specialty Welding Equipment Corporation, expanded. They didn't just make the guns anymore. They made the studs, too. Special threaded studs designed specifically for the welding process. And they made the flanged nuts that secured the top side of the wooden planks, filling the countersunk holes perfectly. It was a complete system. Gun, stud, nut, ceramic ferrule to contain the weld pool, timing controls to ensure consistency, training programs to teach workers the technique. The company operated around the clock. 3 shifts, 7 days a week. The demand was insatiable. Every submarine rolling out of Mare Island used Nelson's system. Every battleship, every carrier, every destroyer, every Liberty ship, every Victory ship. And it wasn't just new construction. Ships damaged in battle came back for repairs. Their decking was blown apart by bombs, torn by torpedoes, scorched by fire. The repair crews used Nelson guns to restore them. Fast, reliable, strong. The USS Enterprise, the most decorated ship in the U.S. Navy, was repaired multiple times using Nelson's process. The USS Yorktown, badly damaged at Coral Sea, got emergency repairs with Nelson guns before sailing to her final battle at Midway. Dozens, hundreds of ships benefited. Ted Nelson's invention was everywhere. By 1943, the Navy's Bureau of Ships conducted a comprehensive analysis of the stud welding process. They wanted hard numbers, proof of effectiveness, justification for the widespread adoption. What they found shocked even the optimists. The Nelson stud welding process had saved the United States Navy more than 50 million man-hours. 50 million. Let that sink in. 50 million hours of human labor, not saved in theory, not projected savings, actual documented verified savings. Ships that would have taken a year to build were completed in 9 months. Repairs that would have required weeks were done in days. Scaffolding costs that would have consumed thousands of tons of lumber and millions of feet of steel tubing were eliminated entirely. If you calculate the equivalent number of workers, it's staggering. 50 million man-hours is the equivalent of nearly 6,000 workers working full-time for an entire year. That's 6,000 men who could be doing other jobs. Building tanks, manufacturing aircraft, fighting on the front lines. All because one welder refused to accept the way things had always been done. The Navy recognized Nelson's contribution in the most prestigious way possible. They awarded the Nelson Specialty Welding Equipment Corporation 2 Army-Navy E citations. The Army-Navy E Award, E for excellence, was not given lightly. It was reserved for companies and organizations whose production facilities achieved exceptional results in support of the war effort. Quality and quantity of production, overcoming obstacles, avoiding work stoppages, maintaining fair labor standards, going above and beyond. Thousands of companies worked for the military during World War II. Only a select few received the E award. To receive two was almost unheard of, but Nelson had earned it. His company had literally changed the way America built ships. In the middle of the greatest industrial mobilization in human history, he had made a critical process faster, safer, and better. The awards were presented at a ceremony at Mare Island. There were speeches, photographs, the presentation of the E pennant to fly over the facility. Workers gathered to witness the honor, and somewhere in that crowd stood Ted Nelson, the welder who had started it all in his garage, probably still uncomfortable with all the attention, probably already thinking about the next problem to solve. But the war wasn't just about production. It was about the men who went to sea on those ships. Think about the sailor stationed on a submarine in the Pacific. He's hunting Japanese convoys through the darkness, underwater, knowing that enemy destroyers are hunting him in return. His life depends on every weld, every seal, every component of his vessel holding together under crushing pressure. He walks across the wooden deck topside during brief moments of surface running. He doesn't know about Ted Nelson. He doesn't know about the stud welding process. He doesn't know that the deck beneath his feet is secured by thousands of welds that were completed in days instead of weeks, allowing his submarine to reach the war zone months earlier than it would have otherwise. He just knows the deck is solid, reliable. He trusts it. Multiply that sailor by thousands, by tens of thousands, by hundreds of thousands. Every man who served on every ship built or repaired with Nelson's process was, in a very real sense, saved by that invention. Not saved from death, necessarily. War is war. Men still died. Ships still sank. But saved from fighting a longer war. Saved from the delays that cost battles. Saved by the industrial might that overwhelmed America's enemies. Victory in World War II was built on countless innovations. Radar, sonar, the atomic bomb, code breaking, mass production, revolutionary tactics, but it was also built on studs. Thousands of threaded studs, welded by spring-loaded guns, securing wooden decks to steel frames. Unglamorous, invisible, essential. The war ended in August 1945. The shipyards slowed. The massive emergency construction programs wound down. America had built the largest navy in the history of the world, and built it faster than anyone had thought possible. Ted Nelson's company transitioned to peacetime production. The stud welding process, it turned out, had applications far beyond naval shipbuilding. Construction, bridge building, automotive manufacturing, industrial equipment. Anywhere that metal studs needed to be attached to metal surfaces, Nelson's gun could do the job. Faster, cheaper, better. Ted Nelson himself moved on from the company, not because of failure or conflict, but because his mind was already elsewhere. Remember, Ted Nelson wasn't a businessman. He was an inventor. Problem-solving was his first love. He invented a hospital bed that rotated 360 degrees, designed specifically for hip replacement patients to aid in recovery. He designed a glider with an emergency engine, they called it the Hummingbird, for recreational flying with a safety backup. He held patents for countless minor devices and improvements. Even into his 80s, Ted Nelson's mind worked like it always had. See a problem. Can't stop thinking about it. Work on a solution. Test it. Refine it. Make it real. He died in the 1990s, having lived long enough to see the Cold War end, to see the Soviet Union collapse, to see the world he'd helped save from fascism transform into something new. But his invention lived on. Today, more than 80 years after Ted Nelson filed his patent, the Nelson stud welding process is still the industry standard. The company he founded, now part of Stanley Engineered Fastening, still manufactures the guns, the studs, the complete systems. They're used to build some of the world's most iconic structures: the Guggenheim Museum in Bilbao, Spain, the Petronas Towers in Kuala Lumpur, Malaysia, the Optus Stadium in Perth, Australia, countless bridges, skyscrapers, industrial facilities, and they're still used in shipbuilding, military vessels, commercial cargo ships, cruise liners. The technology has evolved: computer controls, improved materials, enhanced safety features. But the core principle is exactly what Ted Nelson developed in his garage in 1939. In 2019, workers began a massive restoration project on the battleship Texas, a World War I and World War II era dreadnought now preserved as a museum ship. The wooden decking needed to be completely replaced. The restoration crew needed to attach new wood to the century-old steel frames. What did they use? Nelson stud welding guns. The same technology that helped build the ships that fought in World War II was now being used to preserve one of the last survivors of that era. The ship manager and preservation supervisor praised the Nelson Company for their responsiveness, their technical support, their genuine interest in saving this piece of history. "It has been a really great partnership," they said. "We couldn't do it without them." Ted Nelson would have appreciated that. Not the praise, perhaps. He wasn't the type who sought acclaim, but the fact that his solution to a problem was still solving problems 8 decades later. That's the mark of true innovation. Not the flashy, the trendy, the temporary, but the fundamental, the essential, the thing that just works and keeps working and becomes so integrated into the way things are done that people forget it was ever new. There's a broader lesson in Ted Nelson's story, one that applies far beyond welding and shipyards and World War II. The lesson is this: never accept that something has to be the way it's always been done, just because that's the way it's always been done. Every industry, every organization, every aspect of life has its scaffolding. It's inefficient, wasteful, accepted practice that everyone knows is stupid, but nobody challenges because that's just how we do things. Ted Nelson looked at that scaffolding, literal scaffolding, and said, "No, this is madness. There has to be a better way." And when people rejected him, he didn't quit. He went back to his garage. He kept working. He kept testing. He kept believing that he was right, and the system was wrong. How many potentially world-changing innovations have died because their inventors gave up after the first rejection? The second? The third? How many times have we all encountered something obviously broken and thought, well, someone must have a good reason for doing it this way. Maybe they don't. Maybe it's just inertia. Maybe it's just, that's how we've always done it. Ted Nelson teaches us to question that, to trust our own observations, to believe that if something seems stupid, maybe it is stupid, and maybe there's a better way. But he also teaches us that innovation is hard. It requires more than just a good idea. It requires persistence, testing, failure, refinement, the willingness to work night after night in your garage when everyone else is relaxing, the courage to keep pushing when authority figures tell you no. The 50 million man-hours saved weren't just saved by a clever device. They were saved by a man who refused to give up. As we close this story, picture Ted Nelson one more time. It's late 1945. The war is over. Ships are coming home, their crews jubilant. The Navy is downsizing. Mare Island is transitioning back to a peacetime footing. Ted is probably in his garage again. Not working on the stud welder, that problem is solved. But working on something, always something. A new challenge, a new inefficiency that bothers him, a new possibility. The radio plays. Maybe it's Glenn Miller again. Maybe it's a news broadcast talking about the post-war world. Maybe it's nothing at all. Just the sound of his own breathing, the scrape of metal on metal, the focused silence of a man doing what he was born to do. Outside, somewhere in the darkness, ships that he helped build are crossing the Pacific. Their wooden decks are solid. Their crews are alive. Their missions were completed months earlier than they would have been without his invention. But Ted Nelson probably isn't thinking about that. He's not thinking about the awards or the man-hours saved or his place in history. He's thinking about the problem in front of him. How to make this piece better. How to eliminate that inefficiency. How to create something that doesn't exist yet but should. That's who he was. That's who true inventors are. They see problems nobody else sees. They imagine solutions nobody else imagines. They work when others rest. They persist when others quit. They change the world, one weld at a time. In 1941, Ted Nelson invented a gun that saved 50 million man-hours and helped win World War II. But more than that, he showed us what's possible when we refuse to accept the impossible. When we work through the rejections. When we trust our own minds over the weight of tradition. When we spend our nights in the garage, chasing a solution that seems crazy, until suddenly it's the only thing that makes sense. The next time you encounter something that seems obviously broken, remember Ted Nelson. Remember his spring-loaded gun. Remember his 50 million man-hours, and ask yourself, could I be the one to fix this? Could this be my garage moment? Could this be the problem that only I can solve? Because the world is still full of scaffolding, literal and metaphorical. Waste, inefficiency, madness that everyone accepts because it's always been that way. And the world is still waiting for people like Ted Nelson to say no, to build something better, to save the 50 million man-hours that nobody else thinks can be saved. That's the story. That's the lesson. That's the legacy of one mad welder and his rejected gun, and that legacy continues today. Every time someone refuses to accept the way things are and dares to imagine the way things could be,